your warm-up towards the end. So I'm going to give you a few minutes to think about which one of these doesn't belong and why. So you can talk amongst each other. I'm going to give you a couple minutes to think about it. Let's talk. Which one do we think doesn't belong? Let's go one at a time.
I say B because the X is equal to decimal.
Okay.
And then
I said G because like it's not right as X.
Okay. So
I said B too.
or one.
Same because it's all of them like C is and Y or A is Y or and also like Y equals.
Okay. Any other ones we have for different reasons? Go ahead. Right now. Any others? So there were obvious reasons for all of them. This one, another obvious reason, just comparing them to the others, is the only one in slope intercept form. What would be an obvious thing just by looking at this that's different than the others? It's the only graph. What about C?
Functions table.
It's a table, sure.
Also
What
the
did you
numbers
say?
on it.
I just said functions table. It's probably
They're technically all functions, but what did you say, James? The obvious thing for D would be the standard form. But what if we found the equation for these? Did anyone find the equation for this one?
Y equals negative 1. Wait, Y equals
2x minus 1. Okay. What would the equation for this one be? You do that a couple different ways.
Y equals negative 1.
That would be the one yourself. So you could either think about what your y values are doing as your x values are doing. 2 over 3, but yes. And then did anyone solve this one? Let's do that. So y equals negative 1/2 x plus 2. Now looking at all the equations, which one doesn't belong? And why?
B is the only one found function.
Okay. And the slope?
Yeah.
What else?
T is the only one with positive y-intercept.
Okay. Anything else?
Because all of that knows the minor stuff is negative.
Okay, so for a different reasons, not that it's just positive, but it's also not negative 1. Anything else? Aiden, did you have a reason why one of these equations are not?
A because it doesn't have a 2 in the slope.
In the slope. any of those. So the obvious ones, the ones you guys thought about, and then when you actually solve it, there were differences for each of them. So I said there were multiple answers. Okay. So we are going to continue our graphing notes. Yes.
So which one is going to be wrong?
Oh, for different reasons. So I want to say we did the first 2 pages, but we didn't do this page, right? So let's start on that. Again, if you would like to grab rulers, you're more than welcome to do so. At the top of the page, I'm going to rewrite our close-ups. And rewrite the definition. So that horizontal lines have 0 slope and our y equals, vertical lines have undefined slope and our x equals. So anytime you see horizontal vertical lines, you should be thinking $20. So for number 7, if this is a y equals, it's going to be horizontal or vertical? Horizontal. So on your y-axis, you're going to find when y is -5, try to the best of your ability, the graph is messed up. Put a point at -5, and then we're going to draw a horizontal line straight across. How do you know?
Maybe. Yes.
So for number 8, is it x equals? Is it going to be horizontal, vertical? Vertical. So on the x-axis, draw a point at -1 and draw an up and down straight line. Do number 9 and 10 really quickly. My number 10 is not very straight, but it should be. So if your lines don't look like this, redraw them. And then we're going to think back to slope here for a second, so that we're connecting our slope with our graphs. All the way. Okay. All right. What is the slope of the line y equals 5?
0.
0.
Horizontal lines have 0 slope. What is the slope of the line of x equals -2? Undefined. This one is a trick question. What is the slope of the line of x equals 0? The x equals, so it's still undefined. It's a trick question. They put that there too tricky. you need to be able to recognize the slope of these lines, be able to graph them, be able to, not in this unit, but write them, intercept, all those things. And then let's do this really quickly. So on this side, I'm going to do y equals 3, graph it, and y equals 3x on the other side. Go ahead and graph those two. Once you have them both graphed, what is the difference between these two? What are some differences we see between them? Do they look the same? Okay, so what's different about them?
One's the slope is 0 and one's 3.
Okay. So different slopes. What else? Along with the slopes, are they going in the same direction? One is horizontal, one is slanted, diagonal. What about the equations themselves? What's different? One has an x, one does not. So all of your x equals, y equals, horizontal and vertical will just have a number. The other ones will have input, output. What about x and y intercepts? Do they have both? No. Which one doesn't have both? So this one will always have an x and a y intercept. This one will only have one of those things. So those are things to keep in mind when you're asked to graph these different equations so that you don't graph the wrong one. Okay. We'll go to the next page. So this goes back to, it's very similar to what we were doing when we were graphing, solving our intercepts in standard form. Yes. Yes. Except here we're not going to show all the work we did when we were solving for the intercepts, but we're going to show some of it. So this is cover up the y term, solve for x, cover up the x term, solve for y. So the cover up mathematically would be like what we did when we were solving the intercepts. We put 0 in for y. This became 0. So we dropped that and then set it equal to just whatever was left and solved. Same thing for this one. If we covered up the x, that would be equivalent of putting 0 in for x. This would become 0, and then we just wrote what's left. So with graphing by intercepts, it may or may not say specifically to graph by intercepts. It may just say graph. But if you choose to graph by intercepts, you're only going to solve these two, graph these 2 points, and then draw your line. You should not have more than 2 points with this, because otherwise you're graphing by slope intercept. 2 different things. So for this one, if I was solving for my y, I would cover up the x term, put what's left. In this one, we can skip that first step of putting the 0 in. You can still do it if you so choose. Divide both sides by -2 so that y equals 3. Put a point on the y-axis at 3. Then we're going to do the same thing for x. If we were to cover up the y term and put what's left, that would be 3x equals -6. Solve both sides so that x equals -2, and you would put a point at -2. So you're only going to have those 2 points and draw a line through them. We're not going to continue this. Now, if it says to graph by slope-intercept form, you need to have as many points as possible. But if it does not specify, you can graph it by either converting or doing your intercepts. You have a choice. Questions on that before we move on to the next one? Okay, so for number 2, if we were solving for the y-intercept and I covered up the x term, what would be left? We covered up 2y equals 4, and then we would solve, divide both sides by 2, put a point at 2 on the y-axis. And then do the same thing for x. When we cover up, the y term was left.
X equals 4.
X equals 4. There is no work to do. So you just plot the point at x equals 4. Put a line through those two and graph it. Questions on how to solve this by graphing? Look at numbers 3 through 6, 7 through 10 on the back. Find any questions you want to see, do go over, have questions about. Sure. Okay, so 3 and 9 are going to be the ones we do. So for number 3, if I'm covering up the x term, to solve for y, what's left? Y equals 3. Put a point at 3. What about if I cover up the y term?
X equals.
There's no work on that one. You would just write those two things, plot those 2 points, and graph your line. Sure. So we'll do 6 and then 9. And then do you have your phone today? It needs to be up. Alright, for left?
3.
And then when we divide both sides, we do get 3. And then if we cover up the y term, what's left?
5.
Would be the final answer. But 9x equals 45, divide both sides by 9. So remember that the work part is showing me how you got those answers. How did you solve to graph these? Make sure you're showing that as well as the graph. Questions on 6 before we go to 9? If we are covering up the x term, what's left with y?
Y equals 1.
Close. Negative y. I'm trying to. There we go. Negative y equals 1. To get rid of divide by negative 1. Yes. So that y equals negative 1. If we were getting x by itself or covering up the y term, that would be what?
X equals 1.
X equals 1. That one we don't have to change. Except I put that on the wrong thing. There we go. This should work with that. Remember that this is the only time you can draw 2 points and it'd be okay. But if you're not showing this work, I don't know if you're solving by slope-intercept form, solving by graphing, or intercepts. So show your work and then graph via however you show your work. Any other questions? We are going to switch gears. So before we start the notes for this, I want to mention that there isn't a delta math for this, but there is still practice for it. So when you go on Canvas into this assignment, you have a choice. You can either do the Desmos assignment, or you can do the Go Formative assignment. Whichever one you choose, you have to let me know. That way I can go in and grade it and put that grade in for you. There weren't skills on Delta Math for this, so you have a different assignment. It's still informative. It'll still go in as an informative grade. James, I didn't give you a grade. That will be due on Friday, just like the rest of your Delta Math. So slope part 1, part 2, x and y intercepts, graphing, and the linear transformations activity. All of those are due on Friday. So if you haven't been working on those, you have a lot of work to do by Friday. Keep that in mind. Okay, so for these, there's like some notes we have to take, but there's not really space for it. So in blank spaces, write this information. There are 3 transformations that we're going to be talking about, and I need to put the word wall things up. Where something reflects, where something shifts, and where something is steeper or less steep. So those 3 things are either talking about the slope or the y-intercept. So let's talk about the y-intercept first because it's only one. So for the y-intercept, the only thing that changes for the y-intercept or of those three is if it shifts. And this would be an up or down movement. So if it shifts up or down, you would either see those words, you may not see the y-intercept shifted, you would just say, just hear or see the function shifted up or down by so many units. But it's going to look similar to number 1, number 3, but we'll talk about that here in a second. Okay. So then there's the slope. The other two relate to slope. If your slope is reflected, it's negative. So anytime you think of a negative slope, it has been reflected. We compare all of these to what they call the parent function or the original function, f of x, or y equals x. So like if nothing happened, you would have a slope of 1, y-intercept of 0. And everything is being compared to that. So if a slope was reflected compared to that, instead of it going positively, it would go negative. All right, the other one dealing with slope is it could be steeper or less steep. If the slope is steeper, it's going to be some number greater than 1. So I'm going to put m greater than symbol 1. And we're going to go through some examples that look like that. If it's less steep, the slope will be between 0 and 1. It's going to be a fraction. The steeper and less steep have nothing to do with the reflection. So it can be negative and still steeper. It could be negative and less steep. It depends on the number. So we're going to go through some examples. So you will need to be able to describe what is happening. Did the slope get steeper? Did the slope get less steep? Did the slope reflect? Did the y-intercept shift up or down? Also, graph these things. So you'll need to be able to do both. So we are going to start with number 1. Right now we're just describing. We'll get to the graphing part later. So if I have some f of x plus 2, remember that your original, I'm going to write this somewhere up here. The one that we're always comparing it to is either f of x or y equals x. That would be slope of 1, y-intercept of 0. So if I have some f of x plus 2, this plus 2 is going to be a shift. Plus 2 does not do anything to the slope. So we know already this is going to be something about the y-intercept. Anytime you see a plus 2 or a minus 2, be thinking y-intercept. Something happened to the y-intercept. If your y-intercept was 0, but now it's been added to, what is it at now? Added by 2. is now 2. So we can say that it shifted up 2. So the y-intercept shifted up 2. So when you write the description, you have to say what you're talking about, y-intercept or slope. What did it do? Shifted or reflected, steeper, less steep, and by how much? Yes. If there were more things with that, we would add more. But that's the only thing that changed. That's the only thing that happened. Do we have any questions so far? So now in number 2, we have numbers that are multiplying to f of x. Multiplying numbers is your slope. So now we need to think about what did these two things do to the slope if it was 1, but now it's being multiplied by negative 1/3. So negative means which of these transformations? Reflected. So that's just about this part. The 1/3 would be which of these transformations? Would it be steeper? Is it greater than 1? It would be less. So we would say both of those things. You can either put them in one big sentence or write it as 2. The slope was reflected, and that can be said in multiple ways. The slope is reflected. The slope was reflected over the x-axis or y-axis. And the slope is less steep by 1/3, by a factor of 1/3, either or. So anytime a negative and a fraction or a negative and a number, that is 2 different transformations. This is not on here. But if you had something with negative 1/3 in front and a +2 at the end, all of these things would apply. Something would happen to the y-intercept and 2 things would happen to the slope. Right now we're trying to do this without visualizing, but now soon we're going to visualize. Questions so far?
Did you say it's like together, like slope is reflected and it's
Less steep by 1/3, yes. Alright. So in number 3, this is your original graph, where your slope is 1, your y-intercept is 0. So that original graph is already there. What would this do? What transformation would that do? Shifts up or down? Down by 3. So we can say that. So the y-intercept shifts down 3. Is the slope changing? No. So we need to say that the slope stayed the same. We should actually go back and do that for the other ones, but we'll do that in a second. So get in the habit of describing both what is your y-intercept doing and what is your slope doing for every problem. So if the slope stayed the same and just our y-intercept shifted down from where it is, I'm going to go down 3, plot a point. The directions say only plot 3 points, so I don't need to fill up the graph. I just need 3 more points. So give me 1 more point. Someone give me 1 point that I can use. 1, -2 would work. I need one more point. So you just need 3 points. That's it. We're not connecting them. It didn't say to do that. Now, if it does says connect the line, then you would do that. But that's not what this one says. Okay, I'm going to add in these 2 things before I forget. So this one, the y-intercept changed, the slope did not. And for number 2, the slope changed, the y-intercept did not. So in number 4, what changed? The slope or the y-intercept? The slope. Because there's a number in front. The y-intercept did not change, so that's going to stay the same. What happened to the slope? How did it change? Say that again. Okay, but what does that mean in terms of our transformations? Which of the 3 transformations happened? That's a y-intercept. So it got steeper. If it was reflected, that would be a negative. It multiplied by 2. 2 is greater than 1, so the slope got steeper.
What happened?
Then it would stay the same. So the slope is steeper by 2 or by a factor of 2. So if the y-intercept stayed the same, and I still need 3 points, I can put that point back at the same y-intercept. I need 2 other points that show the slope is steeper by 2. So where could another point be? Say that point again. Would that be steeper by 2? There we go. I need 1 other point. So it doesn't matter if you go up, down. If you want to keep going in this direction, keep going to the left. You want 1 around your y-intercept. You want to skip a couple and do this one, and maybe 1 over here. Doesn't matter. You just need 3 points that would make this true. Questions so far? Now we're going to look at this last one. And we have f of x equals x. That's your original. So if you want to put that or something that tells you this is the original, you don't have to do anything with that. And we have g of x equals 1/4 x plus 7. We need to think about what these words mean. Which one are they talking about, slope or y-intercept, and then apply it. So shifted, is that slope or y-intercept? Y-intercept. So if we're comparing the y-intercept from the original to this new one, what happened? Increase, not by 2, but by 7. So would that be shifted up or down? Shifted up. So this one's just circle which one. We don't have to put more, we just have to circle which one. And then I heard less seat. Why?
Because it's less than 1.
Because about 1/4. Basically, if it's a fraction where the numerator is smaller than the denominator, it's less steep. If it's a fraction where the numerator is greater, it's steeper. Okay. going to start the next page and then leave the last page for. So these are very similar questions, but now they've changed. So we're going to describe, number one, what changed, what happened. You need to rewrite your transformation words on this page. Do that. It did reflect. What reflected? The slope reflected. So those are two different things. The slope reflected because it's negative. That's it. Say that again. And it got steeper because of the 3. What about the y-intercept? Anything happened to it? No, it stayed the same. So y-intercept stayed the same. Okay, and then we have to draw this one. So now we are drawing a line, so we need as many points as possible. So the y-intercept stayed the same. It's going to be at the same point. It's reflected, which means it's now going to the negative direction, and it's steeper by 3. So where could my next point be?
1.
1, negative 3. You got to fill up the graph, so give me another point. 2, negative 6. More points. Now we gotta go the other way. And then
-1. And like
negative 1 through here. Basically the opposite of what we just did. So negative 2, 6. Negative 3, 9. And then once you have all your points, make your line. So I can also see that this one is steeper. Think about like if you were sledding or skiing or something down this hill. You would get down faster down this one faster than you would this one. That's also how you know it's steeper. Questions on that one? What changed in number 2?
Y-intercept.
Got shifted by, or in what direction? Up 2. All of those things. You gotta put all of them together. What happened to the slope? Just stayed the same. Y-intercept shifted up 2. Where is our new y-intercept? 0, positive 2.
Yeah.
The slope is the same, so it's already 1, so you're just going to keep that going. Go up 1, right 1, as many times as possible. And down the left 1 as many times as possible. Fill up your graph and then connect it with a nice line. Questions on 2? Number 3. Again, this is your original, this is the new one. Did the graph shift up or down? Down. And how do we know that? What is a negative? The y-intercept is a negative, so that would be shifted down.
Less,
Why do you think that?
because it's a
It's a fraction. So you have to know those differences, what those are talking about. Number 4 is similar, but now they actually tell you they're talking about the slope here, the y-intercept here. So again, they're comparing. If you want to draw in the original so you can see what happened, you can do that. You don't have to, but you're more than welcome to. I'm going to do that just so you can visualize. The slope is, I'm going to help you eliminate anything more than or less than that's part of shifted, that's part of your y-intercept. So we can get rid of C and D. So compare the slopes. What happened? B. The slope of this new line is 2/3 times more than the original. The same thing for the y-intercept. Y-intercept is not multiplying or dividing, so you can get rid of A and B. So comparing, which one is it? 2, that should actually be 3, not 2. But it's 3 less than. It shifted down 3. So C. Okay, last one and then we'll stop. Do we have any questions so far? Number 5, we need to plot 2 points. We're not actually going to make a line in this one, we just need to plot the 2 points. If this were an SOL question, you would plot the 2 points and it would make itself a line. So if the new graph, so this is our original, if the new graph has been shifted up 5 units, what's our new y-intercept? Give me the order pair. 0, 5. So when it tells you to plot 2 points or 3 points or however many points, your y-intercept should be one of them. That's an easy point. 1/2 as steep. So your slope is 1/2. So you have choices of how you want to do this. We can go up and to the right, down and to the left. It does not matter. Just pick one other point that the slope would follow. Do you have any questions on that? For these type of questions, do not plot more points than what it asks. Plot as many points as it asks. That's it. So, for the remainder of class, you can be working on these things. You have choices, but you need to be working on these things. Hold off on doing the rest of these notes, but if you want to keep working in the graphing notes, you can keep working in that. If you didn't grab a killing zombie, graphing and killing zombie activity and want to do that, you can do that. Or you can be working on any of the delta math / the linear transformations activity that's due on Friday. But you need to be working on one of those 3 things. You can work together, you can move around, you can use demos, your calculator, your notes, all those things. Use this time wisely.